Welcome back, everyone. This is Pamela, and I'll be going through this week's Stata demo. So in lectures this week, Fran talked about how to calculate age-adjusted risk ratios using the Mantel-Hansel formula. Today, I'm going to be going through some of the same calculations that Fran did, but instead of doing them using a pen and paper, we're going to be doing them using Stata instead. So we have two objectives for this week's module. Our first objective is to calculate the crude risk ratio of death for smokers compared to non-smokers in Stata. Our second objective is to calculate the age-adjusted risk ratio of death for smokers compared to non-smokers in Stata. So first, let's just go to Stata and calculate the crude risk ratio of death. All right, so now we're in Stata, and make sure that you have the Framingham Heart Study dataset open, the same dataset that we've been using throughout the course in our Stata demos. Now, the first thing that we wanted to do was calculate the crude risk ratio for death for smokers compared to non-smokers. And to do this, we're going to be using some of the same commands that we've used previously in our demos. So first we go up to Statistics, just click on that, then go down to Epidemiology and Related, and go over to Tables for Epidemiologists. And then from there, go over to Cohort Study, Risk Ratio, etc., and just click on that. Once you do that, a window will pop up, which you've seen before, and first it asks you for your case variable. So this means that they want to know what your outcome is. And our outcome for this study is death. So just click on death. The next drop-down menu asks you what your exposure variable is. So in this case, we're interested in smoking status at baseline, and this variable is called CUR-SMOKE1. So just scroll down until you see CUR-SMOKE1 and click on that. Once you have both of those windows filled in, just hit OK. And you can see that you get the following output on your screen. Now we know that sometimes reading the Stata output in these demos can be difficult. So all I've done is I've copied this output into a PowerPoint slide, which I'm going to go to now to go through the output with you. So right now I'm in PowerPoint and I have the output from Stata. And I can see that this slide is entitled The Crude Risk Ratio of Death, and it shows my Stata commands, CS, Death, CUR-SMOKE1, which you guys also can see in your Stata handout. The top panel just shows our 2x2 table, the number of people exposed and unexposed, and the number of cases and the number of non-cases. Now this bottom panel down here is actually what we're really interested in. This will give us our risk ratio, and we can see that the risk ratio is just the second line. And if we go over, the risk ratio here is 1.07. This means that people who smoke have 1.07 times the risk of death compared to non-smokers. So that means that smokers have about a 7% increase in their risk of death compared to non-smokers. However, though, one of the things that Fran talked about in his lecture was the possibility that the association between smoking status and death may be confounded by age. And this could happen if age was related both to smoking status and to the risk of death. So for example, if people who are younger are more likely to smoke, there'd be an association between age and smoking status. And then we know already that people who are older have a higher risk of death than people who are younger, even if we're only looking among the non-smokers. So since there could potentially be confounding by age, let's instead adjust our risk ratio of death for age. So to calculate the age-adjusted risk ratio of death, first thing I'm going to do is create age categories in Stata. When we have a continuous variable like age, something that ranges from 0 to well over 100, we might choose to actually break it up into categories. It's a little easier to calculate the Mantel Hansel estimates if we do that. So we're going to use the same categories that Fran did in his lecture, and I just have the Stata code here on the screen to go through it quickly. So we're going to generate a new variable called age for cat, and then we'll do 4 different categories: less than or equal to 40, 40 to 50, 50 to 60, and 60 or older. Once we create these age categories, we'll use either the drop-down menu or the command line, whichever you're more comfortable with, to calculate the age-adjusted risk ratio of death. So now let's go back to Stata and go through these commands. So now we're back in Stata, and the first thing that we want to do is create our new age categories. So I'm going to type gen age for cat equals missing, and age for cat is just the new variable that I've created. Then I'll type replace age for cat equals 0, so this is the first category, if age 1 is your age at baseline, is less than or equal to 40. Just hit enter. Now I want to create my second category, so replace age for cat equals 1 if age 1 is greater than 40 and age 1 is less than or equal to 50, because I just want people in the range between 40 and 50. Hit enter. Now I want to do my third category, age for cat equals 2 if age 1 is greater than 50, but age 1 is less than or equal to 60. So people between the ages 50 and 60. And then our final category, age for cat equals 3, if age 1 is greater than 60 and age 1 is less than missing. This less than missing part is basically just to take care of any missing values. No one's missing age in this data set, but we have seen that people are missing things like BMI. So just in order to get into good habits, we're going to make sure that we put in that last part of the command, less than missing. Now that we have our new variable created, we're going to go back up to the statistics menu to calculate our age-adjusted risk ratio. So statistics, then go down to epidemiology and related, and go over to tables for epidemiologists, and then just go down to cohort study, risk ratio, etc. Again, our case variable is still death, and our exposed variable is still Kerr Smoke 1, smoking status at baseline. But this time we also want to adjust for our age categories. So to adjust for the age categories, click on the Options tab at the top. Once you've clicked on the Options tab, you'll see a little box that says Stratify on Variables. And just click the box next to Stratify on Variables. And now hit the drop-down menu to choose which variable we want to stratify by. And we want to stratify by age for cat. So just click on that. And if you notice, right below that window, we see a within stratum weights, and the button next to Use Mantel Hansel should be selected. And that's because we want Stata to use the Mantel Hansel formula to adjust for our age categories. So once you've done that, just hit OK. And we can see that we get this panel of output here. And I've just copied this panel of output into PowerPoint so that we can read the output a little bit more clearly. So now we're back in PowerPoint, just copying the panel of output from Stata into PowerPoint. And this is the age-adjusted risk ratio of death. I have the commands that I used at the top if you're more comfortable using the command line than the drop-down menus like I showed previously. And we can see that the output actually shows us the 4 different age categories. So we notice that we have 0, so these are people in the first age category. Their relative risk is 1.79. That's right here. People in the second age category, though, we can see that they have a slightly lower relative risk of death. And the last category, the 3 right here, actually have the lowest risk of death. At the bottom of the screen, we have the crude risk ratio of death, which is 1.7. That's the same as what we saw earlier. And then the final line is actually the MH combined. This is a Mantel-Hansel estimate. And our Mantel-Hansel estimate is right here. It's 1.38. This means that after adjusting for age, people who are smokers have 1.38 times the risk of death compared to people who are non-smokers. So that means that after adjusting for age, smokers have 38% increase in their risk of death compared to non-smokers. Now that's pretty different from our crude estimate. Our crude estimate was just 1.07 versus our age-adjusted estimate is 1.38. And the fact that there's such a big difference between the two helps support the idea that there probably was confounding by age. And in order to see the true relationship between smoking and risk of death, we should adjust for age in our analyses. So that's it for today. Our next data demo is actually going to look at the incidence ratio of death and how you can age adjust the incidence rate ratio of death. Thanks, guys.